Welcome to the discussion on a numerical problem from the topic total pressure and center of pressure. Here we are considering a vertically immersed lamina. Question is this: determine the total pressure and position of center of pressure on an isosceles triangular plate of base 5 meter and altitude 5 meter when the plate is immersed vertically in an oil of specific gravity 0.8. The base of the plate is 1 meter below the free surface of oil. In this kind of problems, the position of the plate immersed should be shown by a suitable line sketch. This is the isosceles triangular plate. 5 meter is the length of the base and 5 meters is the altitude. We know that its center of gravity lies at a distance of 1/3 of the altitude from the base. So when you consider an isosceles triangular lamina, its center of gravity is at a distance of 1/3 of the altitude from the base. And here the altitude is a symmetrical one. Now in what orientation it is immersed? Whether the base is below or the base is near to the free surface. See, from the given information, the base of the plate is 1 meter below the free surface of the oil. See, the altitude here is 5 meters. So the base is 1 meter below the free surface. So that means this is the only possibility. We have to hold this lamina vertical. See, this is the orientation. We will consider the oil on one side of the plate. Here this is the edge view of this triangular plate, and the base of the lamina is represented by AB, and the altitude is MC, and altitude is 5 meters, and the base AB is below the free surface by a distance 1 meter. And where is the center of gravity? See, its centroid is located on the symmetrical axis here, that is the altitude, at a distance of 1/3 of the altitude from the base, that is this mg, that is h by 3. So this mg is h by 3, and on that level we have represented our reference centroidal axis xx. See, we have the reference centroidal axis xx here at a distance of 5 by 3 plus 1 meter below the free surface. 0 level, that is the free surface level, is here, and from there 1 meter below we have the base of the triangular lamina, and again from there at a distance of altitude by 3, that is 5 meters divided by 3, that is 1.667 meters, will be the depth of the center of gravity below the base. So therefore total 1 plus 5 by 3. So that will be the distance h bar. So h bar is the depth of the center of gravity of the lamina below the free surface. We know that the center of pressure lies below the center of gravity in the case of vertically immersed surfaces. We have proved it also. H star is the distance from the free surface to the line of action of the total pressure. What is total pressure? It is designated by F. That is the resultant hydrostatic force acting on this plate is represented by F, and its line of action is at a depth of h star meters below the free surface. We know that h star is greater than h bar. And now how to find out h star and this magnitude of force F? Density of oil we can find out from the available specific gravity. Specific gravity of oil is given as 0.8. So 0.8 into density of water, that will give you density of the oil. So that is 0.8 into 1000, 800 kilogram per meter cube. That is the density of oil here. What is its specific weight? We know that in SI units, specific weight W is equal to rho into G. So specific weight of oil here represented by small w is equal to 800 into 9.81. So that is 7,848 Newton per meter cube. That is specific weight of oil here. And what is the area of the triangular plate? That is half BH. The base is 5 meters and altitude is also 5 meters. So half into 5 into 5, that is 25 by 2. So 12.5 meter square. Now let us find out the value of area moment of inertia or second moment of area of this triangular plate about its own centroidal axis parallel to the free surface. Centroidal axis is this XX that passes through G. We know that the area moment of inertia of the triangular lamina about its centroidal axis parallel to the base is given by BH cube by 36, where B is the base and H is the altitude. So we have to recollect that expression for use here. Now the depth of the center of gravity below the free surface. I told you that already. G is at a distance of 1 plus 5 by 3 below the free surface. That is 0, 0 level. So this XX and the free surface level, they are separated by the distance h bar. So h bar is equal to 1 plus 5 by 3, that is 2.667 meters. OG is equal to OM plus MG. OM is equal to 1 meter, MG is equal to 5 by 3. So OG is the distance h bar. So h bar here is 2.6667 meters. Now moment of inertia of the plate ABC about its centroidal axis XX parallel to the free surface. So IG is equal to BH cube by 36. BH cube 5 into 5 cube divided by 36. You will get 17.3611 meter raised to 4. See the unit of area moment of inertia. Since the dimensions are in meters, the area moment of inertia IG here is in meter raised to 4. And now we are in a position to find out both the total pressure force and also the center of pressure location. What is the total pressure? The resultant hydrostatic force acting on the immersed isosceles triangular plate. That is given by WAH bar. And W is the specific weight of the oil here in which the plate is immersed. That is 7,848 Newton per meter cube. Area of the plate is 12.5 square meters. And H bar is the depth of the center of gravity of the lamina below the free surface, that is 2.6667 meters. So you will get F is equal to 2,61,603.3 Newton. And if you want to convert that into kilonewton, divide it by 1000. So you will get 261.603 kilonewton. So this is the total pressure or the resultant hydrostatic force acting on the vertically immersed triangular plate given here. Now what about the location of the center of pressure? Center of pressure means the point of application of the total pressure force on this vertically immersed lamina. So the depth is designated by H star. So we will find out that next. We know that H star is equal to H bar plus Ig by AH bar. We have derived this expression for vertically immersed surfaces earlier. So the location of the center pressure, H star is equal to H bar plus Ig by AH bar. H bar is 2.6667 meters plus Ig is 17.3611 meter raised to 4 divided by area 12.5 meter square, and H bar is 2.6667 meters. So H star will be 2.6667 plus 0.5208. Therefore, the center of pressure is at a distance of 0.5208 meters below the center of gravity. See the distance between the center of pressure and center of gravity, that is H star minus H bar, is this term Ig by AH bar. See that Ig by AH bar, if you take the product and evaluate this fraction, then you will get 0.5208. So distance between the center of pressure and center of gravity is this. So here you will get H star is equal to 2.6667 plus 0.5208. So you will get 3.188 meter. So this is the depth of the center of pressure below the free surface, or the point of application of the total pressure force F. With this I wind up this lecture. Have a happy learning experience. Thank you so much.